going to show you how. Again, CBR, growth birth rate, CDR, growth death rate, TFR, total fertility rate, DT is demographic transition, is how population is changing depending on the geographical situation, and NIR, that is natural increase rate. Calculation. So it's a formula that is not complicated. So CBR equals total numbers of births times 1,000 over total population. And growth death rate, total number of deaths over total population times 100. Remember that is growth because we are not considering the age or sex structure of a society. The highest birth rates are in LEDs. In MEDs, birth rates and fertility rates have fallen. Why? Because they have more money to prevent natality. They have birth control. Now, another formula, total fertility rate, average number of births per woman per lifetime. For example, I have 2 kids. Another teacher has 2 kids. So the average is 2 kids per woman. Okay, depending on the lifetime. Maybe in 35 years, they're having just 2 kids until the age in which they can have more kids. So natural increase rate, NIR, this one is the easiest one, CBR minus CDR. That is the natural increase rate. Then we have the doubling time years. So it's the amount, you can calculate that watching the data that you have like in the previous slide. Or apply this formula, 70 over percentage growth rate. All this data you're going to have in tables, so you just have to get the data and calculate. Why 70? Doubling time is the time it takes for a population to double in size. Assuming growth rate remains constant, an average life expectancy of 70 years. So they are considering this life expectancy. What is life expectancy? That more people in this planet is going to live up to 70 years. It is sometimes called the rule of the 70. So, how do you use this data to calculate CBR, CDR, TFR, DT, and NIR? So, in this table you have the years from 1985 to 2002. You have the mid-year population. At the mid-year, what is the population? Live births, so birds that are alive, deaths, natural increase, net migration, total. So, in this one you have the most important information, growth rates. We have the birth rate, CBR, CDR, growth death rate, per 1,000 is already calculated, the growth, the natural increase, and the total. So using that information, you can see what was the formula to calculate natural increase. CBR less CDR. So 13.9 less 10 is 3.9. Okay? And so on. Can you arrive at these same figures based on the numerical data provided? Apply the formula from your textbook or student handbook to the numbers in the columns of left. We have an example, we have an exercise what we are going to do next class, okay? You have in the textbook and to do activity about how to calculate that is not difficult because you just have to apply the formulas, but we're going to do that next class. So explain the relative values of CBR, CDR, TFR, and NIR. Again, we have this demographic picture with the different stages that I already explained. And this is the last activity, okay? So we just have like four activities, individual activities that I want you to do. Just one line, one paragraph per every single one. So describe how each of these, CBR, CDR, TFR, impacts total population on its own. So they are changing and they're going to affect the population growth, as you can see. I just want you to explain that. Then decide how each one influences or impacts on each other. This one influences this one, and both are going to influence that one, right? Predict whether any one of them has a larger impact on the total population than any of the others and justify the prediction. For example, if we have more birth rates, the population is going to grow exponentially. But what is happening now with the